On July 30th, 1908, moments after 7 in the morning, the sky over Siberia split in two. In the Tunguska region, a roar shook the taiga as if the world was breaking from the inside. Witnesses spoke of a white, burning light that crossed the horizon, so bright it blinded for a few seconds. And then, the blow. An explosion so brutal it threw people to the ground and shattered windows hundreds of miles away. Back then, there were no cameras, no satellites, no way to understand what was happening. There were only villagers, hunters, and traders lost in the middle of the forest. One of them, Semyon Semyonov, lived about 40 miles from where it all happened. Years later, he told what he saw with his own eyes. He said the sky split in two, and fire appeared high above the forest, that such intense heat hit him that he felt like his shirt was burning, and that the sky closed with a crash and a blow that threw him to the ground. In the nearby village, people spoke of a ball of fire that crossed the sky and of a glow that lit up the taiga, followed by a roar that resembled artillery. Some thought a military depot had exploded, others that end of the world had come. No one knew then that they were witnessing the largest cosmic impact humanity has on record in modern history. For several nights, the sky over Europe became unusually luminous, as if sunset never ended. According to current calculations, the explosion released energy equivalent to between 10 and 15 megatons of TNT, at least 500 times more powerful than the Hiroshima bomb. The place where that force fell was a green hell of swamps, birches, and conifers, so remote that years would pass before anyone managed to reach it. What at first was a flash in the sky became an impossible rumor to verify. Over time, the Tunguska event transformed into one of the great mysteries of the 20th century. An explosion capable of flattening an entire forest and turning the sky bright thousands of miles away without leaving a single crater. And even today, the same question persists. What can destroy more than 800 square miles without leaving any visible trace? In 1908, Russia was still an empire ruled by Tsar Nicholas II, the last of the Tsars. It was an enormous country, so vast it stretched across 11 time zones from Europe to the Pacific Ocean. Modernity advanced slowly. In many villages, there was no electricity or trains, and people lived almost the same as a century before. At the heart of that immense Russia was Siberia, a wild land of infinite forests, frozen tundra, and swamps. Winters reached 50 degrees Celsius below zero and lasted half a year. Life in the Russian Empire oscillated between two worlds, that of ancestral superstitions and that of a science that was just beginning to emerge. In the villages, most still believed in omens, spirits, and signs from the sky. In the cities, a small group of astronomers and physicists dreamed of deciphering the secrets of the universe. The Imperial Academy of Sciences, based in St. Petersburg, had minimal resources and a handful of researchers trying to apply the modern theories of Newton or Laplace to a country that still prayed for good harvests. The Russia of the Tsar was simultaneously medieval and modern, a paradox floating between faith and physics. That's why news traveled there with desperate slowness. There were no planes or roads, and the telegraph only worked in a few important cities. So when the sky exploded over the Podkamennaya Tunguska River, the event spread by word of mouth among traders, hunters, and shepherds, becoming an impossible rumor to confirm. The Evenki, a nomadic people from northern Asia who lived from hunting, and their reindeer herds were the main witnesses. They were experts at moving through the taiga and believed that nature was full of spirits. For them, what happened that day could only be a sign from the sky. They spoke of a ball of fire crossing the horizon, of a fire from the gods or thunder spirits punishing the earth. Each one told something different, but all agreed on the same thing. The air became as hot as a bonfire, and the ground shook under their feet. Some swore the trees burned without touching fire, and others that the sun itself had fallen on the forest. The phenomenon was so massive that even weather stations across Eurasia, from Russia to England, detected anomalous alterations. Barometers recorded pressure waves that traveled around the planet. For several nights, strangely luminous skies were observed, though no one knew yet they were related to what happened in Tunguska. Astronomers and meteorologists found no explanation. Some thought perhaps a comet had exploded in the air. Others believed it was an unusual aurora borealis or a giant electrical discharge. The only clear thing was that something enormous had happened in Siberia. So, out of the ordinary, that early 20th century science didn't yet have the tools to understand it. Meanwhile, European observatories recorded atmospheric disturbances that no one knew how to interpret. It seemed as if something had thrown dust and gases into the highest layers of the air, but the origin remained a mystery. Over time, scientists calculated that the energy released had been one of the largest explosions recorded in modern history. The most baffling thing was that there was no visible trace of the supposed meteorite, only a flattened forest and an impossible silence to explain. For years, theories multiplied. Some believed a meteorite had fallen, others that it was a volcanic eruption, or even a failed experiment. But in 1908, no one had been able to reach the site. Between the extreme climate, the distance, and government disinterest, the mystery of Tunguska would remain unanswered for almost 20 years. Throughout all that time, the place where the mysterious explosion had occurred remained a lost point on the map. No one had organized an official expedition, and the few scientists who tried to investigate barely managed to get information. By the time the new Soviet government began to stabilize, that event was already a half-forgotten story told by peasants and Siberian hunters. But then someone appeared determined to solve the mystery. His name was Leonid Alexeyevich Kulik, a former soldier of the Tsarist army who had studied physics and mineralogy before the war. He had fought in the Russo-Japanese War, where he was taken prisoner and spent months in a detention camp. That experience marked his character. He was disciplined to the point of an obsession and had almost inhuman patience. Back in Russia, he survived years of poverty, giving classes and working in small museums before entering the meteorite collection of the USSR Academy of Sciences in Leningrad. There he found his purpose, to prove that meteorites weren't simple curiosities from the sky, but key pieces to understanding the planet's history. Kulik had spent years compiling meteorite reports and was fascinated with the idea of finding a crater the size of a city. If he proved that Tunguska had been caused by a real impact, he would not only solve the mystery, but also provide key information about celestial bodies crossing Earth's orbit. In 1921, he tried to investigate the area, but bad weather and lack of economic support forced him to return. It wouldn't be until 1927 that he finally got permission and resources to venture into the heart of Siberia, thus beginning one of the toughest scientific expeditions of the 20th century. The journey was a true odyssey. The taiga was a green hell of rivers, swamps, and mosquitoes that devoured the skin. Storms erupted without warning, sleds sank in the mud, and compasses lost precision among the mineral deposits in the soil. The team suffered from fever, frostbite, and hunger. They advanced with sleds and canoes carrying provisions that rotted before arriving. The Evenki, this nomadic people who obviously knew the region better than anyone, agreed to accompany him as guides, though they warned him the place was cursed. They said animals avoided the heart of the forest and that after storms, strange noises were heard, like thunder coming from the ground. Kulik, however, didn't believe in curses. In his diary, he wrote that he was stepping on the land where the sky fell. For him, That terrain wasn't a forbidden place, but an open door to knowledge. While he made his way through the Siberian wilderness, the world was living another revolution. In Europe, Einstein was publishing his theories about space and time. In America, Charles Lindbergh was crossing the Atlantic by plane. Humanity dreamed of conquering the sky, and only he, among swamps and birches, was trying to understand how that same sky could destroy part of the world in seconds. After weeks of march, he finally arrived at the heart of the mystery and was left speechless. Before him stretched a flattened forest as far as the eye could see. In his diary, which is still preserved in the Russian Academy of Sciences archives, he wrote, "The trees lie on the ground, all oriented in the same direction, as if a hurricane had swept them from the central point. In the middle, some remained standing, naked, charred, without branches. They look like blackened posts. The destroyed area was immense, comparable to the size of a large modern city. The fallen trunks formed a perfect pattern pointing to a central point, indicating the explosion had occurred in the air." But when Kulik reached the epicenter, he discovered something unexpected. There was no crater, no hole, no rock, no visible metallic remains, only swampy ground covered with ash and charred trees. That void puzzled him. He dug in several spots, measured the orientation of the trunks, and took soil samples to analyze in Leningrad. He searched for fragments of iron or nickel, the typical minerals of meteorites, but found nothing that explained such a brutal explosion. The silence of the place made everything even stranger. Witnesses said no birds were heard, the air smelled of burnt resin, and the terrain seemed crushed by an invisible force. From a nearby hill, Kulik observed that the fallen trees drew an almost perfect circle of tens of miles, the footprint of a disaster so enormous that a century later it's still visible from the air. A year later, in 1928, he returned with a larger and better prepared team. He carried topographic instruments, cameras, and compasses. To observe the terrain from above, they built wooden towers and took the first panoramic photographs of the area. The images confirmed the radial pattern of destruction he had described. Ground zero of a colossal explosion that occurred in mid-air. Despite everything, the mystery persisted. Kulik was convinced the meteorite's core had to be under the swampy ground, perhaps trapped in the permafrost, the layer of frozen earth that never thaws in Siberia. So he wanted to excavate with heavy machinery, but the logistics were impossible. There were no roads, and the terrain devoured any vehicle. Everything had to be transported on sleds, pulled by horses or reindeer. During the 1930s, Kulik returned several times to Tunguska. Each expedition was harder than the last. The weather, mosquitoes, and lack of resources weakened the team. He tried new methods, from magnetic detectors to giant magnets, hoping to find metallic fragments hidden under the earth, but never found conclusive evidence. In 1939, shortly before the war began, he was planning to return with heavy machinery, but the project was canceled with the outbreak of the world conflict. Even without solving the mystery, his work was crucial. Thanks to his reports and measurements, scientists understood for the first time that Earth could be hit by objects from space much larger and more dangerous than believed. Decades later, science would confirm what Kulik already suspected. Kulik returned to Leningrad, present-day St. Petersburg, with one conviction. What had flattened the Tunguska taiga hadn't impacted the ground, but had exploded in the air. His hypothesis was that a meteorite, entering the Earth's atmosphere at full speed, heated so much from friction that it ended up disintegrating before touching the ground. In that instant, it released gigantic energy, sufficient to flatten the forest without leaving any crater. It was a risky idea, but it was logical. Kulik calculated that a body of rock or metal traveling at more than 15,500 miles per hour, about 20 times faster than a bullet, reaches temperatures of thousands of degrees. When the pressure overcomes it, it explodes in midair, producing a shock wave similar to that of a nuclear explosion. In the 1920s, many scientists considered that explanation crazy. No one had seen such a phenomenon, nor were there modern records confirming it. But he was convinced. It was the only way to explain what he had seen in Siberia. The big problem was the lack of physical evidence. If it had been a meteorite, why were there no fragments left? His expeditions found no remains of rock or metal, and soil analysis showed no clear traces of iron or nickel, the typical minerals of meteorites. The devastation was evident, but the origin remained a mystery. In the 1930s, a more elegant theory emerged: the ice comet. Several European astronomers, among them Britain's Fred Whipple, proposed that the object that fell on Siberia wasn't a rock, but a dirty snowball, so to speak, composed of ice, dust, and small stones. Upon entering the atmosphere, the heat would have completely evaporated it, causing an explosion without leaving solid fragments. For years, this idea dominated the debate, as it explained the absence of visible remains and the circular pattern of the forest. But it didn't quite fit either. If it really was a comet, traces of water or carbon should have been found in the soil, and there weren't. Chemical analyses carried out in the 1950s by the Moscow Institute of Geophysics confirmed the ground was dry and the heat had been extreme, which coincided more with the explosion of a rocky or metallic body, that is, an asteroid, than with an ice comet. At the same time, other Soviet scientists explored even bolder theories. Some spoke of a cosmic energy discharge, a radiation current from space that would have detonated spontaneously upon contact with the atmosphere. Others mentioned a cloud of interstellar dust compressed by Earth's magnetic field. None of these ideas survived empirical scrutiny, but they showed how much Tunguska had become a laboratory of scientific imagination. In the late 1950s, a group of Soviet scientists led by Kirill Florensky and Vasily Fast returned to study Tunguska with more advanced technology. They took samples at different depths and found tiny spheres of iron and silicon, so small they could only be seen under a microscope. They were drops of molten metal that had cooled in the air, a chemical footprint of a space object disintegrated in the atmosphere. Analysis performed by Evgeny Krinov confirmed the presence of nickel and cobalt, typical elements of meteorites. Although the quantities were minimal, the finding was crucial. It demonstrated that something had arrived from the sky and had completely vaporized, leaving a microscopic trace. Over time, Kulik's hypothesis prevailed as the most coherent. A celestial body, probably an asteroid, exploded in the air, generating such enormous energy that it flattened more than 800 square miles. It was, as I've already told you, the largest non-nuclear explosion recorded by humanity. Kulik never got to see his theory confirmed. In 1942, during World War II, he was captured by the German army and died in a prisoner camp. His work was so meticulous that later scientists were able to reconstruct the mystery from his notes, maps, and measurements. Decades later, thanks to satellites and computer simulations, science would end up confirming what he had already intuited in the solitude of the taiga. The Tunguska monster came from the sky and exploded before touching the ground. More than a century later, science has managed to reconstruct a good part of the Tunguska mystery. Not everything. There are still loose pieces, but enough to understand what happened that June morning in 1908. For decades, researchers only had testimonies, old photographs, and Leonid Kulik's notes. But the 21st century changed the rules of the game. Thanks to satellites, computer simulations, and modern chemical analysis, it was possible to review the case from scratch and understand how such an enormous explosion could leave no crater. The most solid studies, conducted by the Institute of Physics of the Russian Academy of Sciences, together with international teams, point to the phenomenon being caused by a bolide, a celestial body between 160 and 200 feet in diameter, formed by rock or a mixture of ice and cosmic dust. Upon entering the atmosphere at more than 16,800 miles per hour, it heated so much it disintegrated between 3 and 6 miles above the ground. The explosion released colossal energy. This type of phenomenon, called an airburst, doesn't touch the Earth, but its shockwave can be devastating. In Tunguska, that pressure ripped out millions of trees and generated an atmospheric wave that literally went around the planet, recorded even by European barometers. The reason there was no crater is the object never impacted the ground. It exploded in the air, vaporizing completely. The wave descended with tremendous force, sweeping the forest from above. Modern models confirm that the pattern described by Kulik, charred trees in the center and knocked down outward at the edges, fits perfectly with this vertical area detonation. Over time, analyses added new evidence, like the remains of nickel and iron that were found, which, together with simulation models, ended up confirming that the Tunguska monster did come from the sky, but exploded before touching the Earth. The impact also transformed life in the taiga. Studies of tree rings show that in subsequent years, the forest grew more vigorously. When old trees fell, more light entered and vegetation regenerated rapidly. In a way, the explosion acted as a natural ecosystem reset, destruction that gave way to life. Even with all modern technology, enigmas still remain. No large fragments of the object have been found, and some models can't exactly reproduce the tree fall pattern. This suggests there may have been more than one explosion, or that the burst was more complex than believed. There's also no consensus on its final composition. It's unknown whether it was an asteroid or a comet. Both theories fit, but neither completely explains the phenomenon. And yet, the study of Tunguska has left an immense legacy. The analysis methods developed to understand it helped define protocols for detecting hidden craters and created models to identify atmospheric explosions in other parts of the world. More than a century later, the place where the explosion occurred seems to have returned to normal. The forest grew again, covering the ground that once burned intensely. Today, reindeer, moose, and bears walk among the young trees as if nothing had happened. If someone arrived there without knowing the history, they would never imagine that on June 30th, 1908, the Earth trembled with a power capable of flattening an entire region. For a long time, humanity looked at the sky as something distant and calm. Tunguska shattered that illusion. It reminded us that Earth isn't alone, but is surrounded by thousands of bodies traveling through space that occasionally cross our path. A giant asteroid isn't needed to cause a catastrophe. A rock the size of a building moving at supersonic speed is enough to release energy capable of erasing an entire forest. Today, the Tunguska area is a protected natural reserve. The State Nature Reserve of the Tunguska event, founded in 1996. The few visitors who managed to get there after hours of travel through dirt roads and dark water rivers can walk among the young trees growing over the remains of the original forest. Under their roots still lie the charred trunks from that day when the sky split in two. In the nearby village of Vanavara, a small museum remembers the story. Inside are preserved Kulik's original photographs, fragments of burnt wood, and models that reproduce the devastation. Every year, researchers and travelers leave messages in the visitor's book found there. Where once the fire from the sky fell, now only the wind among the pines is heard. Time erased the visible scars, but not the lesson. Tunguska remains a mirror of our vulnerability, a reminder that even the most remote places bear the mark of something that came from space and changed the Earth forever. Today, we know that event wasn't an isolated incident, but a warning about the sky. Up there, beyond the atmosphere, thousands of asteroids and comet fragments cross Earth's orbit in silence. Most pass by, but some graze, In 2013, that chance reminded us of its power again. A meteorite barely 65 feet wide exploded over Chelyabinsk in Russia. Its shockwaves shattered thousands of windows and left more than 1,000 injured. It was a small version of Tunguska, but it was enough to demonstrate the danger is still there, hidden in the immensity of space. Since then, humanity has been watching the firmament with great attention. Missions like DART, which managed to divert the orbit of a small asteroid, have marked a before and after. For the first time, we're trying to protect the planet from the same sky that threatens it. A tiny gesture, but loaded with meaning. Still, astronomers repeat it with calm and resignation. We can't see them all. There are more than 33,000 asteroids cataloged as near-Earth objects, and hundreds of new ones are discovered each month. NASA's Planetary Defense Coordination Office and its European equivalent, the ESA Planetary Defense Office, scan the sky every night, searching for possible threats. But even with all that technology, some objects go unnoticed. A call that crossed time to remind us the sky isn't always a refuge, but also a force. And although we now have telescopes, radars, and supercomputers monitoring space, we still partly depend on luck. That same luck that saved so many people in 1908. Sometimes in the observatories of the Atacama Desert or in the snowy domes of Hawaii, a solitary astronomer looks at the screen where points of light blink. They know one of them could be the next visitor, like that morning over Siberia. And while the world sleeps, the universe continues its course, indifferent. And up there, the silence keeps writing its history. Because even though we understand almost everything that happened, no one can assure that something like this won't happen again. That's been everything for today. I'm sorry if this has been a bit catastrophic or I've put in a bit of fear, but well, let's hope no asteroid hits anyone in any near future. Thank you so much for watching this video. If you don't know what to comment, leave me this emoji and I'll respond or give you a like as soon as I can. And now, yes, with nothing more to say, see you in the next one.